All right, this is lesson number 1 for a group of problems that are actually going to come from a couple of different places in your textbook. The more basic ones are coming from A5 and A6, which are those extra sections in the back of the text, and then from the main text, section 2.7. Basically, what we're going to be looking at are absolute value equations and inequalities and nonlinear inequalities. We're going to start off with some stuff that should be relatively basic for you, and then slowly work our way into things that are a little bit more pre-calculus appropriate. As far as fitting this into the bigger picture of why you would need to know this, what happens with inequalities like this, and then the absolute value that we're going to get to in the next slide or two, is you spend some time on it in Algebra 1, and you leave it alone, and you don't really come back to it. Then in Algebra 2, usually it's one of the first topics in the beginning of an Algebra 2 class, and you leave it alone, and you don't come back to it. But it turns out that these types of problems are things you need to know for SAT purposes, for ACT purposes, and those of you that will have to take college placement exams, they tend to be very common on college placement exams. So although they don't get built upon very much in terms of the world of standardized testing, this is some stuff that you should be proficient with. All right, so starting off with problem number 1 here. This is a basic linear inequality. What we're going to do is go through the same set of steps we would go through to solve this as if this was an equal sign. Except at the end of each one of those steps, we have to check to see, does that need to flip or does it point in the same direction? If we multiply both sides by a negative, if we divide both sides by a negative, or we trade sides of the inequality, then the arrow has to flip. If we don't do one of those things, it stays pointing in the same direction. All right, so step 1 here is we have to clear those parentheses by multiplying through by -3. Okay, clearing parentheses is never going to flip the arrow. That's not doing anything to both sides of the inequality. Okay, that gets us to here. Then combine your like terms. Combining like terms will never flip the arrow. That's just doing something to one side of the inequality. Next step, to get from here to here, we're dividing both sides by -6. Division by a negative number to both sides of the inequality will flip the arrow. That gets us to the final answer using more of an Algebra 1-ish notation, using interval notation, which is more common at the level we're at. It would look like that. Right, very often, you will be asked to, in addition to solving, or instead of solving, expressing your final answer in graph form. So, you should always show where 0 is, locate the key number, which is 2. At that key number, it's going to be a closed circle, because we have that line underneath the inequality. And as long as the letter's on the left and the number's on the right, the shading matches the arrow. So that would be the graph of that final answer. All right, next 2 examples are compound inequalities. And in this case, we are connecting with an and. In this case, we're connecting with an or. So, whether it's an and or an or, we're going to start the problem by independently solving the 2 inequalities. So, for starters, from here to here, I just flip sides. I like it to have the letter on the left whenever reasonably possible when I'm dealing with inequalities. That flipping sides of the inequality will flip the arrow. So now it becomes very basic. Subtract 1, divide by 2. Neither of those moves cause the arrow to flip, so this solves the left half. Here, this is a one-stepper. Divide both sides by 3. Division by a positive number is not going to flip the arrow. So this is one way to express your final answer. X is greater than 3 and X is less than or equal to 6. But with and problems, very often you can blend it to a single 3-piece inequality like this. So x is greater than 3, and at the same time it's less than or equal to 6. And interval notation will look like that. Okay, if you were to graph that, we would want to show 0. 3 roughly here, 6 roughly here. Closed circle on 6 because of that equal sign. Open circle on 3. And that would be your graph. Okay, number 3. Again, for a compound inequality, solve each one independently. So subtract over the 3, divide by the 7. Neither one of those moves would cause the arrow to flip. Add 1, divide by 4. Neither one of those arrows would cause the arrow to flip. I'm sorry, neither one of those moves would cause the arrow to flip. And OR statements very often will be replaced with that union like this. It could be this, could be that. The way that those graphs look, they tend to be two arrows that point off in opposite directions. So we're looking at 0. Negative 3 is roughly down here somewhere. 8/7 is between 1 and 2. So we got open circle on both. So we've got going that way. Going that way. All right. On to number 4 now. Here we have a compound inequality that's got that three-piece flavor to it like we did here. So for the simple ones that look like this, where you can isolate x in the middle, that's your strategy. Now you can't always isolate x, or in this case your variable will be n, in the middle. And we'll talk about that strategy in a moment. So for this one here, we want to try to get that x by itself in the middle. The way that we're going to do that is subtract 5 from all three parts. Minus 5, minus 5, minus 5. Subtraction is not going to flip. Addition, subtraction never flip the arrows. Divide through by 2. That gets you to here. Division by a positive number never flips the arrows. And that produces a final answer that looks just like that guy right there. Finished up the same way. All right, these 1 through 4 examples you should have had experience with in both Algebra 1 and in Algebra 2. Moving up the food chain a little bit here, number 5 has got that three-piece inequality, but you're not going to be able to isolate that n in the middle. So we need a little bit more of a sophisticated strategy. So what we're going to do is break it up into an and statement. This is less than that, and at the same time, that thing in the middle is less than that. Now, once we do this, it becomes the same as number 2. Solve this, solve that. If it's an and, it makes them both true at the same time. Now, I kind of glossed over getting to that graph because it's kind of, somewhat obvious in that situation. If it's not quite so obvious how these things blend together to get the interval notation, an approach you could take is graph the first one. N greater than negative 6 looks like this. N less than negative 1 looks like that. If it's an and, what makes them both true at the same time, or where do those two things overlap? So the intersection of those two graphs is right there between negative 6 and negative 1. So if it's not necessarily obvious, like perhaps this one maybe was more obvious than that, that's the strategy you take in order to identify your final answer. All right, so again, wrapping up, 1 through 4 should be familiar with from previous math classes. This number 5 strategy may be something new. I'm not really sure, depending on what level of math you had and who your teacher was, but that wraps up the first slide. All right, now on to a couple basic absolute value equations All right, so for absolute value equations, you want to first isolate the absolute value by itself on one side of the equals. So for this particular problem, it means you have to subtract over the 2 and divide by -5. Once you get that absolute value isolated, you're going to split this up into 2 equations. What's inside the absolute value equal to that as is. What's inside the absolute value equal to the opposite of that. Because once you take the absolute value, that stuff that was in here, whether it was +3 or -3, once you take the absolute value, it gets you to there. Solve each one of these independently. All right, absolute value equations have a high risk of extraneous solutions. You always have to check these guys. So when you check them, plug it back into the original. If it works, great. If it doesn't, then it's extraneous. I'm not going through the mechanics of that in the interest of time. At this stage of the game, that's something that you should be more than proficient with. It turns out for this particular problem, both of those check back in the original. All right, moving up the food chain slightly. Here, this one, we have variables both in and outside the absolute value bars. It doesn't affect the overall procedure. The first thing that we're going to look for is, do we have this thing isolated? In this case that we do have it isolated. So that means we can go right to the split. What's inside the absolute value equal to that as is. What's inside the absolute value, the opposite of that. And since that has more than one term, ultimately you have to make sure that that gets distributed. Okay, solve each one of those guys independently. For this particular problem, they're just basic, simple little pre-algebra equations. We get our 2 potential solutions. Absolute value equations have a high risk of extraneous solutions. They always need to be checked. When you check them, make sure that you put them back into the original. In this particular case, the -3 turns out to be extraneous, but the -1 does work. And when you have variables both inside and outside, that's usually a little higher risk than this case here of obtaining the extraneous solutions. It can happen in either situation, but a little bit more common in these guys here. All right, next step up the food chain here. Now we're mixing in absolute value with inequalities. All right, so whether it's an absolute value equation or an absolute value inequality, the first move is you have to isolate that absolute value. In this case, it's already isolated. In this case, it's already isolated. If it wasn't, we would want to take care of that first. The next move following, whether or not it's an equals or an inequality, is it needs to split. Okay, the pattern for the split, what's inside the absolute value, same direction, same sign. What's inside the absolute value, flip the arrow, change the sign. Now, if it's a less than is always going to have a connecting word of an and. And the way that I remember that is you can kind of make an A out of a less than. Now, once you do this move and you split it up into 2 inequalities like this with the connecting word, you are right back to one of these 2 guys that we did on the first slide. This is going to finish up the exact same way that we did numbers 2 and 3. And in the interest of time for this video, and the fact this is something you should have seen before, I'm not going to go through the mechanics of this step. Refer back to numbers 2 and 3 as far as the steps go. Okay, number 9, it's an absolute value, whether this is an equals or an inequality. We need to isolate, then split. It's already isolated. Okay, the pattern for this split for an inequality. What's inside the absolute value, same direction, same sign. What's inside the absolute value, flip the arrow, change the sign. Okay. Greater thans will always have an or for a connecting word. And my memory trick for that is you could spell greater with an or. You didn't spell it very well, but you did spell it with an or. It's similar to what I just emphasized with number 8. Once you do this split, it's going to look exactly like one of these two guys right here. Mechanically finish up number 9 the same way you would have finished up number 3 here. All right. Now, this is probably venturing off a little bit further than what you would have seen in Algebra 1 and or Algebra 2. The overall concepts are the same, but probably a little bit more going on in terms of the details of each step with these guys here. All right, so big picture here is we have an absolute value equation. The rule is, or the set of steps, we want to isolate that. That's already done for us. After the absolute value is isolated, this needs to split. For an absolute value equation, what's inside the absolute value? Same as. For the equals, it's always an or for the connecting word. What's inside the absolute value? Opposite of that, or the negative of that. So that means ultimately that negative sign has to follow through. Now, what distinguishes this problem from what you may have seen in Algebra 1 or Algebra 2 is now we've got a couple of quadratics to solve. So the little pieces inside the big problem have a little bit more stuff going on. So we need to solve that. So mechanically at this stage of the game, not going to go through that. Just as a general reminder, what are your options to get that solved? Hopefully it factors. If it doesn't factor, you may have to complete the square. You may have to use the quadratic formula. Okay, solve this. So now we have 4 potential solutions. -3, +2, +6, +1. Okay, there are no cool math teacher secrets in terms of which ones will work, which ones will not. There's no information being withheld here. This is just a long process of each one of those guys. You would have to plug in and check to see what works and what doesn't. So it turns out, for this particular problem, that we get 2 extraneous. The 2 and the 6 are no good. The -3 and the +1 do end up working. All right, so comparing this one to this one, here we had a quadratic inside of absolute values and linear outside. They flip orientation here. The overall set of steps is not going to change. So for an absolute value equation, what's inside the absolute value equal to that as is. What's inside the absolute value equal to the opposite of that. For equations, it's always an or for the connecting word. For an inequality, it possibly could be an and or an or. Refer back to the last couple problems to remind yourself of which is which. So now we've got to solve this quadratic, solve this quadratic. So that's pretty clean. We're getting 2 potential solutions of 0 and 3. It turns out this one, we don't get any real number solutions. And we're not considering any imaginary solutions here. We're only concerning ourselves with real number solutions here. So this one here can't be factored. And if you try to do the completing the square or the quadratic formula, you're going to end up getting imaginary solutions. We're not concerning ourselves with that. Of the 2 possible solutions we get, turns out both of them work. They both check. All right, as far as what we are doing for day 1, this is a wrap. Okay, recapping in terms of overall scope. Oh, you know what? I skipped. I apologize. 10 and 11. I just realized it was stuck to the back of the other one. So, let's go back and hit those real quick. And then we will be done. And I'll do the recap. All right, so this falls into the category of, what do we have here? So this, probably something you should have seen in Algebra 1, Algebra 2. Slightly messy because of the fraction, but other than that, it's pretty straightforward. So it's an absolute value, inequality. What's inside the absolute value? Same direction, same signs as is. What's inside the absolute value? Flip the arrow, change the sign or the signs if it's got more than one term. This is a less than. Less thans are always ands. So a little bit more going on in terms of the mechanical steps to get the left one solved. A little bit more going on in terms of the mechanical steps to get the right solved. But again, that's basic algebra at this particular point of the game. And that leads us to our final answer. If you need to, again, you could do the two graph method to see where they overlap. Let's do that real quick. So 0 and 8 are key numbers. So less than or equal to 8, closed circle on 8, heading to the left. Greater than or equal to 0, closed circle going to the right. If it's an and, you want the overlap of those two guys. All right, last problem. Here we have absolute value on both sides. So this is kind of, potentially it looks intimidating, but it's really not at all. It's almost common sense that we have to do. If those two things are the same, that's going to be true. Or if those two things are opposites, they're going to be true. So if that's like positive 5, negative 5, you have to take the absolute values are the same. So we're just going to take that idea here and write out two equations. That equal to that as is, or for opposites, you just have to make one of the sides negative. For equal signs with absolute values, it's always an or. Whether there's one absolute value or two absolute value, always have the high risk of extraneous solutions when it comes to absolute value equations. Turns out that those guys both check. All right, so quick recap. Putting this stuff in order now. Ultimately, where we are in the textbook here, a couple different places. The A5, A6 stuff in the back, that should be a review of what you've seen in Algebra 1, Algebra 2, extending a little bit into more of the pre-calculus range. The 2-7 stuff, we didn't really quite get to that. We kind of touched on a couple basics, but 2-7 as is will be the focus of the next couple lessons. All right, as far as your homework goes for tonight, this video was made for the 22-23 school year. The homework lining up with this will be out of the textbook, so check out Google Classroom. If you are viewing this at some other school year other than 22-23, then I would check Google Classroom and see if it's possibly a worksheet or something else.